shows us workshop. Ok, Gonçalo, vamos começar. Vou-te apresentar e depois podes começar.
Yeah.
So, welcome to the last session of the symposium. You're very brave to have stayed this far. They have no energy to share, otherwise they would. So this next paper is going to be presented by Gonçalo Castro Henriques. It was co-authored with Márcio Nizambaum and Tatiana Teixeira from the Rio de Janeiro Federal University. Their presentation has the title Information, Shaping Tools, Composition Rules, Visual Thinking, and Creative Processes. Please go ahead, Gonçalo.
Well, first, thank you for the invitation. Thank you to the organizers, David, Franklin, George, and all the team together and for this seventh edition. So I'm very glad to be back in a way, to Porto, even if it is virtual return. So I'm in Rio de Janeiro, where I teach at the Federal University. So I will start by sharing my screen. Please tell me if you can see my screen. So
Yes, everything's fine.
as Katarina already introduced, our paper is titled Information, Shaping Tools, Composition Rules, Visual Thinking, and Creative Processes. So this is a work I did with two colleagues from the Federal University, Márcio and Tatiana. This research is based on a work of a course unit called Conception of Form for Architecture, and is one of the in the first semester is a foundation course, and we have an introduction about classical and modern treatises, so like Vitruvius, Duran in the classical, and in the modern Van Duisburg, Kandinsky, Corbusier, and we introduce the students to aesthetical and visual perception, together with visual thinking by Colin Rowe, Ching, and all these references. So as you see, this is a theoretical and practical course. So before the pandemic, this course was all done by hand in physical development, drawings and models. And during the pandemic, we introduced computational tools and computational thinking. That's something that already had some connection with. I don't see my screen.
Yes, there's been a little problem.
Okay, maybe I should wait a little, but I can continue explaining a little like this that I'm intending to show to you here. Um, is an experience we did to join the physical and the digital in a hybrid process. I think I'm back there. Hope the cable now is connected. Uh, so this exercise is a classical exercise for beginners in design courses around Europe and North America. It's called 9 square grid. So I will show you around how we adapt this exercise. So we start giving the foundation of aesthetics and, as I told you, and visual thinking. But then we start to analyze with the students different compositions, so they can understand the structure, the qualities, the rhythm, the forms. So we tend to ask them to look at the some references more abstract, neoplasticism, Brazilian constructivism. So they by themselves they choose the compositions, and then we discuss this in class. So this exercise it starts in the ninth grade. Starts by physical experience. So we cut a series of forms that are based in the human dimension. Later on, we'll introduce the parametric jaw, that is a change for the digital extension. But basically, they have three blackboard sheets, so they cut this manually to have 9 squares, 9 big squares, 36 smaller ones, and the same relation for the triangles. They have like 36 smaller triangles and 9 bigger ones. So they are all done with a classical ruler and cutter exercise. So to explore this. And then we ask them to develop 5 compositions, one, for example, only with squares, or the other only with the triangles, other with triangles and squares, and two that are more open. So every student brings this to the class, and we use a projector and we discuss about these qualities they are developing, this rhythm, the balance between closed, empty forms, and also to explore these kind of patterns. We like to think about emerging patterns in a way. This is not something only for the digital. We try to search for these emergent patterns and these aggregations. So these are some of the examples the students develop. As I told you, we do these different compositions to start, and then to introduce them to the 3D thinking. We encourage them to think more about material qualities in a three-dimensional point of view. Also, our exercise has an interior space, so this is something we will work with in the digital more closely. We give them some examples of the kind of design that we want. We ask them to do a design for a park that has a space for shelter and a promenade through the space. Um, Also, this idea that we already exploring in 2D about patterning, light, heavy and light structures. So we give them some examples. And then through these examples, they try to rebuild this 2D. And here we go back to the previous only manual development. Like here we see 5 compositions done by hand, and the 3D in a physical model. And normally we ask them to develop parallel thinking, so that, for example, in the upper image, we can see they are doing research through volume and subtraction. On the other model, we can see planes. And finally, the model that is closer to us with the materials is kind of final result, the students used to work on the physical model only for this exercise. So here we can see some of the examples. We could argue like here we also see the application of the materials in a series of designs by all the class. So what they need here to explore is also their dexterity to cut, to do these nice models like in traditional schools. But one thing that we notice is like when we do it only by hand, they tend to be overlooked as an object that is from outside, so they don't enter so much. I remember when we used to do this also in ESAP in Porto, we used to sketch a lot to understand the interior space. This is not so much an option nowadays because students are not so much told how to draw in a fluent way. But so here I will explain a little the how what we teach them so they can use also the digital tools together with this physical experience. So we basically give the students two classes. One is we draw the reference is the parametric jaw. The difference here is like every student has his own height, so his own parametric model. And then we make a kind of translation from the 2D to Rhino so we can have a starting point for the 3D exercise. The other thing that we do after, and this is also connected with design, is we give them two different visual languages so they can start. So one of the languages is based in planes. The kind of transformations that we apply and that we teach in a program with the less possible commands in Rhino is more related with movement, with space, with balance. So it's kind of a way of modeling. We can see on the upper image different ways of modeling with different planes. But then we teach them another way that is using volumes and there's subtractions, additions, interceptions. So this is another way of modeling. So we use the idea of visual language to have a kind of a pattern. But this is like an introduction, so with the tools and the references. But the idea is they develop an interior space, as I told you. An interior space, in a way, they explore this promenade, they explore this way through the space, the balance. So they bring the idea of composition from 2D abstract meaning to compositional 3D promenade in the space. They are here we can see three different 2D. Finally, the bigger one was chosen for this composition. So you can see their own human figures. This is very important because when they show the design to the other colleagues and to the class, they are supposed to enter the space to show the way through. And this way we can see how the scale is, if it's too full of form, that if cannot breathe, if it's that is a balance. So they explore this inside the space and not from outside the space. So this is there are some examples, and also something that we realize is like only with the little not much tutorials. We tell them how to make different ways of building and extruding form in this in different directions. So they tend to have a more variety of solutions. But one thing also we try to teach them is like repetition and difference. They really have a place in this kind of visual patterns because otherwise, if it is all different, everything changes. Like this is something like the digital promise, like the infinite solutions. So we also try to teach them that to have limits and bounds is good. So it's good. A system can be defined, but what it can do and what cannot do. So limitations is not necessarily something bad. By the contrary, we work with this. So here we see some more examples of this 3D. They explore from inside and outside. Here you can see like 3 or 4 materials. These materials came from the physical models. Here we see a class of uh, developed during the pandemic, only digital. Um, so basically, this is what I wanted to bring to you. This is not necessarily something new, but this is another way of working that is not so much exploring the way of combining things. So first we start with 5 compositions in 2D. So we develop this abstract intuition, patterns, repetitions, difference. Then we advance only 2 dimensions for 3 digital proposals. So in this way, we work more with transformations, with the path, mass, void, scale, light. So they must enter this space. This is no longer a sculpture or something abstract. They must inhabit this space. And with the process following, we choose only one of these 3D, but they have experience by trying different proposals. This is also, we believe this is good, so they can explore not only one shape, but a family of shape. This is also connected with the digital variants. So they develop one in particular and they apply the materials because the third, before they have no materials, only on the selected one. And also material is part of the project in the way it enhances like the plane or the volume language. So material in an abstract sense, because it's only 3 or 4 materials, but is part of the project. And then finally, they end up the projects in 2 ways that are complementary. That is the physical model. They end with the physical model. But in another way, we do a virtual immersive experience for the class, or we try this. We are not doing this all the time, but we already tried, is that everyone has the own glasses, virtual glasses, and we can walk in the class game solutions, let's say. So it's a kind of field walk. So here you can see some of the models that we start developing with the students. This is kind of for one semester. This is kind of half of the semester, this exercise. So these are some physical models. Here we see the digital one with the that is done now before the physical, and so we rely on different qualities to use this. For instance, of course, you know the digital model has no weight, no way of testing structure, and although some models are take much more time to build, they are much more effective to test other stuff. But and this you can read a little more in the paper about the advantages and disadvantages. But what we want is to have both, not to exclude. This has been a long discussion, because all the times people ask if we only have physical or only have digital. No, we want both. They have their qualities. So this was what I had to share with you. I hope that it could be useful in a way, and thank you very much.
Thank you, Gonçalo. Gonçalo will have to leave shortly, as he left.
Yeah, if there are some questions,
Yeah, if someone has questions about this presentation, please ask now, and then the other 2 will be at the end. Are there any questions?
Hi, I have another question, actually more that I was kind of fascinated by your proposal, because it's so much, we just redid our education on the bachelor level, and we have introduced a course which is very similar to your course. So I think I will put you in contact with the with the examiner of that course. I think she will be fascinated. What we did there, so we do the same thing, let's say combining the digital models with the physical models, and we iterate between them and learn the students what brings to one, what can you use the one for and the other. But we do two other things that you didn't do, and I thought it's maybe nice to share. So we add a function at a certain moment as an iteration. So suddenly this sculpture or this thing that they have made, three-dimensional, becomes a toilet. So they have to sort of put in, so suddenly accessibility becomes important and the functionality. And then the last iteration is that we put it in public space. So suddenly the city and the flows within the city also become part of the logic. So it's maybe we have more time probably in that course, but it has the same pedagogy, I think, that you have, and I think it was very nice to see. So I will put you in contact with her if you think it's
Okay,
okay.
what's your name?
My name is Meta Berghuis-Pont from Chalmers, Sweden.
Okay, thank you, Meta. This was very interesting to know. But do you use this nine square matrix, or only
No,
the
no, it's
method
not.
you?
No, we use it. No, they don't use that. But somehow the
Yeah,
results are very similar to what you are doing. So I don't know the details exactly how they introduce the first exercise, but
okay.
it has a lot of similarities in also what is produced. So
Okay.
let's. I think I can share the. We have a sort of a description of the course. I can share it with you.
This will be really nice. Thank you. I will just try to explain a little more, commenting on what you just said. Uh, I ask about this particular nine square grid because when we start using it, and this is a long exercise, like with more than 20 years that is done in our faculty, or even if it was only analog, it's a long tradition. But only recently we found this is an exercise that is all over Europe and the US. So we didn't know this that this somehow it's on a first exercise by John Hayduke. As long as we saw, and this is also in the paper. And you're right about the architectural and design function. We do ask this for them. What we ask is they have to have certain conditions on their 3D composition. They must assure a path. They must have an only one entrance, so we can recognize entrance through form. And also they have to have some sheltering, and this is not a building, but some sheltering in this. So also this you can find more in the paper, so it's more detail about. But of course, this is very important because this makes the design not only form oriented, but the form, and we do it with the scale because they have to walk inside the scale, the promenade, and also architectural feature in a way. And just to comment about this is only one exercise of three in a semester, and it's the first exercise they do. And the first idea was from the older generation, it will be very difficult to use digital and physical. But the students, they really shown us that they are very quick to learn. We only teach them 2 classes of digital, and with very not a lot of commands, and really simple. And so I'm happy that you also have this hybrid exploration. So I will be glad to have to know your work at Sweden. Thank you.
Thank you. Um,
Alessio.
Hello. Yes, my name is Kaiko. I'm from Estonia. I just want to second that. We also have quite a similar course
Perfect.
with digital production in timber this year. We actually cut them out from my wood board in the end, so they made the models, and yeah.
Okay. So maybe I can write down my. You have access to the proceeding books, right?
yes, everyone does.
Yeah. So we can change information.
Mm.
So I don't know.
And anyone, if any of us, of you emails us a question about anyone else's contact, we can share that as well. So are there any more questions? I think that's it, Gonçalo. Thank you so much.
Thank you.
So the next.
I can stay online a little more to maybe to see the next one. I don't know. I will just switch the camera, but
please stay.
Okay, thank you very much. And congratulations again.
Yeah, the next presentation is by Bruno Marques. It is presenting the paper Parametric Software and Architectural Design.
Okay. Hello again. I'm presenting a cross-boundary of a project that was developed between the academia and our office. And we try to use software that could allow us to take decisions in the construction and also the performance of the building. It's about an old building from the 18th century in Montfort, and it's this building right face to the city council. So the city council is the second project it's ongoing, and this building, it was a case study for the students for the last year of the faculty to develop an internal project, because this was a ancient convent that was transformed to a house. And the actual client decided to refurbish the interior of the building. And the students had to develop internal configuration according to the new proposal of the use of the building. And the main concern is how to understand this kind of building. This building was built in, as I said, 18th century. It has a higher inertia solution to improve the comfort. Does not have any kind of insulation as we had before. It's typical from this area. This is in Alentejo, high Alentejo. It's interior part of Portugal, in the warmer part of the country. So in summer, it's very hot. In winter, it stays very cold, like Castelo Branco also. So we needed to understand how was the behavior of the building in the thermal comfort and also in the demand of energy. Should we keep the inertia as the solution? Should we introduce insulation? What kind of proportion between inertia and insulation? So we decided to make some studies, and we used the rhinoceros and grasshopper to understand the performance of the building. We also found some plugins. It's attached to the grasshopper. It's Ladybug, and allow us to understand the solar energy and the thermal behavior of the buildings where we can study. It's across software that we can introduce BIM, the drawing in BIM, and then modulate him and introduce the information of the thickness of the wall, the characteristic of the walls, the windows, the glazings, the roof, all the internal configurations, and try to extract information. But this is a freeware software, the Ladybug and the others, cousin softwares that are attached to each other. I will show you which one. So they are not very well performance, so they have some bugs, and we are trying to work with that. So it's an ongoing process. It's not a closed solution. So as I said before, this is the main square of Montfort. The building is right here. This is the city council. And we needed to adapt the building to the new demands of use, and also, and the most important, as I say, the energy poverty that we have to deal in Portugal. Our cost of energy is very high, and part of the population, 18% of the population, is struggling to pay the electrical bill. So they They have to suffer somehow to not use the heating systems because they cannot pay them. So we have to study solution that should be the most passive way as possible. Nowadays we call it bioclimatic, and or introduce heating systems or cooling systems in extreme situations in shorter weeks or shorter periods to compensate the performance of the building. This is the jungle of softwares and plugins that we have to deal. Ladybug, it's here. And we can analyze the configuration and geometry of the building. We have the butterfly that's attached to the Ladybug and it makes the connection to the honeybee, and also the Energy Plus. So there is a group of plugins that we can work within the Grasshopper. So it can we introduce information, and we don't have all the information that we needed, but still we could get some outputs. And with these different plugins, we can extract information that allow us to take decisions in the early phase of the project. We are used to work with contemporary buildings in concrete, with insulation, with new technology, but when we have to face to heritage buildings, to ancient buildings, to different kind of construction solutions, we really don't know how to work with them. Using the same solution and improving without changing too much the configuration of the building. We are used to see colleagues that they just create an internal envelope of the original building. They insulate it within and work from that point. But they are not working with the building as itself. They use it as a shell. Because they cannot understand, they cannot have technology and also time to understand the process of what is the behavior of the building. We could use some data loggers that we dropped on the building in summer and in winter, and we could get information of the performance and the difference in the levels of temperature around all the day during several weeks. So we could understand that those almost horizontal lines are the ones that are close to the thick walls of stone and earth. So it's a mix between earth and stone, the construction solution of the walls. And as we go upper levels in each floor, the curve of the temperature starts to increase until we get to the roof. So we start to understand what is the inertia of the building, and each floor it decreases the inertia because it's must be a slimmer wall, so we have less inertia, and we have to introduce the insulation. But since the late 19th and beginning of the 20th century, the construction system, it was attached to the way we get light inside of the buildings. It was using the fire. So the energy to get light, it was around 1%, and 99% of the energy, it was heat. That heat goes to the walls and could hit the walls, and with inertia could stay for a couple of hours. When we started to use electricity, that paradigm changed a lot. But we took too many years, too many decades to adapt the constructive system to change from inertia, mostly in Portugal, we are talking about Portugal, mostly from inertia to insulation. And this change of paradigm between the heating system of the burning, the wood that could be used for the stove, for the fireplace, for the lighting, it was leaving a lot of energy on the surrounding environment, but also could eliminate the moisture of the walls, but also burn the oxygen. So we needed to have higher ceilings, and at that time we have much more cubic meters rather than we have now. And we could not have so very good insulated windows because we need to introduce oxygen during the night while we were sleeping, and we needed to keep the fire working at the same time to have enough oxygen. But nowadays we are in the opposite direction. We are insulating too much the buildings. We are not introducing proper air. We are insulating everything, and we are just giving away the inertia. And this is important to explain to the students, that we have to understand the building as a whole, not as its shape, not as its construction system, but as a whole, as a living building, and with this interaction between energy solutions and the existing building. And the importance of this is it's very transformative for students, because they need to understand that each building, each season, each decade, each century, it brings a different construction solution and way to use the buildings. And we have to transform the buildings for the contemporary use. So we have to transform also the way to bring comfort. And the way we choose to introduce new solutions, it must be not only in a theoretical and conceptual choice, but also in a thermal comfort and energy at the same time. And these kind of softwares allow us to understand more the way the building it will react to its environment, not only to the climate, but also to its surrounding, to the shadowing of the buildings. On this page, we can see the solar orientation of the building, so we can understand during the year what is the movement of the sun around the building, and what are the facades that could be more insulated and the ones that are less insulated. And we can see in summer and also in winter the incidental lights around the building, and understand what facades we should be more careful to insulate, and which one we should open more windows or allow the sun to get in. This page is also about incidents or radiation, the same concern about the energy that the building receives all over the year. This is in July, August. And the next one in February, January, February, and the winter. And the amount of energy that the building can get from the sun, and how, or if we can use it in a proper way to improve the passive solutions and try to minimize the demand of energy that we can, and we have, of course, to introduce in the building, but in a smaller scale, so in less costly monthly use. Also about ventilation, another important concern, and also mostly in summer. This building, it has a huge part, it's called Mirante. It's a higher point of the building that has nice views around all the village, but it works like a chimney. And the use of these possibilities allow us to ventilate the interior of the building in hot summer, like we could bring the cold air from the streets and use the chimney to pull out the hot air. And the wise way how we can bring the cold air from the basement or the ground floor that has high inertia, so cold air, and to introduce it in upper floors without losing the soundproofing and comfort between each floors, it's also a concern. And this kind of informations allow us to take deeper decisions and more informed considerations to choose what path we should have to go while we are sketching, while we are discussing the configuration with the client, and explaining the client that this is factual. This is not a conceptual idea. This is not theoretical idea of the architect. This is factual information that we need to bring to the client and show them that we are really concerned on the real use of the building and also the performance of the building. And here the thermal comfort graphic, we can see as it is now, what is the red? The red one is the comfort zone of the building, and the blue one uncomfortable. And we can see that inertia still have a very important role in this region. So we should not take it out and just insulate the building and create an internal shell that destroys this technology that's somehow very, very useful. And the second graphic is about the bioclimatic chart, where we can understand that it still can be in a comfortable region all over the air, but of course there are some periods that it requests heating and cooling, and we have to improve that. So the strategy are very, very, for now are very basic, but we have the first one, the functional reformulation of spaces. They need another configuration. And we, of course, we have to reconfigure the routes, the paths between the interior of the building, because those paths are also for ventilation. It's a way that we can bring the ventilation using those paths, those routes from the different floors. And also the use of the roof area. At this moment, the roof it's empty, so it's very cold in the winter and very hot in summer, but the client needs to use the roof. So we have to study how to bring comfort to the roof. That's the most part that has high incidence of solar radiation, most energy of radiation on the building. So we have to introduce a lot of different strategies to ensure ventilation and insulation to somehow to use this part, because it was not expected to be like that. And of course, preserving the aesthetic elements, the language, the image of the building, application of insulation materials very wisely and in a very careful way. So we could improve the quality of the building and the performance, but without eliminating the inertia as the main concern. Of course, the windows are the one that should have a higher efficiency, but we also should study the way we can bring ventilation to the interior without losing the comfort of the insulation, and also the soundproofing. That is another concern, because centuries ago we didn't have cars making noise at night, so it was okay to open the window in the upper floors to the streets and could bring the cold air. But nowadays in our cities we need to close the windows because the noise, it's also a big concern, and we don't know how to deal with that if we have cars moving around the old part of the city. And obviously the structural reinforcement and use of local materials. Here we are concerned to use the materials as earth and very light materials to try to replicate the same solutions, but in a new configuration. And we have a very clear idea of the process. This is the model in the cardboard, and the plans in the lower part with internal configuration. It's under evaluation to the client, and we expect to have a good output in the further months. So this is the main concern is to show that we are in the beginning of the use of these softwares for a very pragmatic and very useful way to understand the original buildings and how to make the best choices to improve them, but in a very wise and very careful way, not change totally the configuration and totally the original idea of the building. So this tries to resume what I've been saying, telling this on this presentation. Thank you.
And now the last speaker of today and of the symposium. I'd like to present David Leite-Viana, who is presenting a paper he co-authored with João Quintão and Rui Fernandes, and is entitled Combining Space Syntax and Kernel Methods in the Delimitation of the Matosinhos Pressure Zone.
Well, hi again. Thank you. First of all, thank you. Well, I'm really glad to have this final session with starting with education, and again goes to architectural, and now finishing in urban scale. So I think this is a nice way to close the symposium. And what I have to show is a little bit of my work in the municipality of Matosinhos. As you know, most of my work now is there. So as I said previously, I'm now more in the implementation of formal methods in the planning environment practicing, and not that much on research of methodologies, etc. So what I'm going to show you is not actually nothing new. It's just the way you use it, combining it in terms of responding to a request from the Lady Mayor to address one of the problems that Matosinhos has alongside with other municipalities, that is related to housing scarcity. So we did this work starting with a statistical analysis of the position of Matosinhos regarding the annual rate of change in the medium value of sales per meters of family homes, and try to understand how what kind of correlation we could establish between the cost of to rent an apartment or to buy an apartment and what people gain, what the salary of families in Matosinhos, and the timeline in this process. And what we understood through this statistical analysis is that Matosinhos is one of the municipalities where this relation between what people has to pay or to spend to rent a house regarding what they earn from their work is quite unbalanced situation. So it's a hard effort to do it, and is increasingly with time. On the left you have 2021, on the right you have 2022, and this situation is aggravating through with time. So alongside with the political executive in the planning division, we start to think about how to address this problem. And before we developed the municipal housing charter, we explore a possibility provided by law is to increase the municipal tax for buildings from 6 times to 12 times in a period, in a very short period of 6 years, I guess. That could be enclosure in what the legal framework calls as a zone of urban pressure. A zone of urban pressure is considered to be one in which there is significant difficulty in accessing housing due to there being a scarcity of or inadequacy of housing supply in relation to existing needs, or because the supply is at values higher than those bearable by most residents without them being burdened with housing costs compared to their income. This is the situation I told you about. So the specific limitation of an urban pressure zone is based on the combined analysis of a time series of indicators relating to housing market prices, family income, or housing shortage, including the characterization of the stock to be selected from among those listed in the attachment to this decree law, of which it forms an integrated part based on the social, demographic, housing, and market dynamics presented in this specific territory. So this is what we did. We went to the law framework, and within it, we tried to understand what kind of data we could gather to go to the delimitation of this urban pressure zone. Due to our experience of the territory, of course, we had an idea of what kind of delimitation this could be or where it could be. But we didn't want to have this only empirical or intuitive approach to the delimitation, because this is an issue that deals with the pocket of people. Because if you go to say to someone, look, your house now is on the under urban pressure delimitation zone. Your tax, if you don't put it on the market, your IMI, is the municipal tax, is going to high from 6 times to 12 times what you pay now. So it is a social, sensible question. It's not a light decision to include or not to include a vacant house within urban pressure zone or not. So we look at the data that we could gather and some other municipalities that already had delimited their urban pressure zone. Some of them use the delimitation of the entire municipality. The administrative limit of the municipality is the urban zone pressure. Lisbon used this criteria. Other municipalities use the criteria of establish the urban zone pressure related to the limitation of ARUs. ARUs are the areas for urban rehabilitation. So if you have an urban rehabilitation area, you put it into also into urban pressure delimitation. We understood that those kind of quite linear criteria weren't useful for our municipality. So we tried to understand what kind of other approach we could set to reach this delimitation. So a common ground between those municipalities who already had delimitations for urban zone pressures is the resident population, a kind of population density framework. So we decided to also have that. As the problem is the vacant houses, because the idea of urban pressure zone is that houses or plots where you can build, if they are stopped for 2 years without being put in the market to rent or to sell, or to have a kind of a building proposal there, then you will start to, the owner will start to pay higher levels of taxes. So we understood that if the vacant housing were the core of the issue, then we went to understand what kind of data we could gather. We have in Matosinhos municipality data regarding this topic, and also we use data from Deloitte, who gathered this sort of information, and we gather 10,000, about 11,000 vacant housing information data from those houses. And we started a georeferenciation process in GIS, and we divide low consumption and no contract. Low consumption is related to the houses that have electricity or water contract, but they have low consumption registers, or no contract at all regarding water or electricity. And the other sort of the data that we use is related to the requests. Matosinhos have a municipal company that it's called Matosinhos Habitat that deals with housing issues. And they have a register of all the requests regarding people asking help, asking the municipality to help them to find a house, or asking the municipality to help them to pay the rent that they have. These are two different problems. The first ones are the more serious one, because these are people that don't have a house where to live, and they are asking the municipality to help them to find. The other ones are those already living in a house, but they cannot afford to pay the totality of the rent, and they go to the municipality and ask them to help to pay part of the rent. So within this, Matosinhos Habitat has 1,518 requests, and we start also to a process of geo-referentiated all of these in GIS environment, alongside with the 763 requests from rental support requests. So we start with the population. We use data from census from the National Institute for Statistics, and we start to understand the distribution of the population within the municipality, as most of the municipalities that already delimited the urban pressure zone did. They use this data as one of the pillars for the delimitation of the urban pressure zone. We then, as I said, we georeference. We put on a GIS environment all the requests that we have from. All the requests, no, all the registers that we have from vacant house. So these are all the houses that exist, but they are empty. They are not fulfilling their function to serve as a house for a family. After that, we separate those universe of houses in those with low consumption and those with no contract. And you are starting to getting a pattern as long as I go through the slides. You start to understand there's a convergence between where people are asking for helping the municipality to find a house, where people are asking for the municipality to help them to pay the rent, and where the vacant houses are. So there's a pattern here. This is again the process of geo-referencing all the housing requests. Here is not separated. Here we separate the ones to support the housing rental, and then we did an examination analysis of the average rental support. This is actually the record of where the municipality spent more money helping people to pay the rent and where it doesn't happen. So this is where there are more people needing to the municipality to help them to pay the rent, and the yellow one is where is less. So we have all this data, and we start then to try to understand the relative weight of these indicators: resident population, vacant housing, housing request, and rental support request. So we start to establish a sort of scenarios where we use different ponderation for these indicators, for these scenarios. So in scenario number one, we decide to give a higher weight to the population density and a lower ponderation to the vacant housing, and an even lower ponderation to the requests to help the rent. Why? Because the requests to help people to have a house, it is here in a higher ponderation weight than the request to help to pay the rent. Why? For the reason that I already told you before. The first ones are the ones that do not have a house and they need the municipality to help them to get one. The other ones, they already have a house, but they cannot afford the totality of the rent. So we ponderate this, and we use this criteria to understand if we changing the weight of these indicators, we would have different analysis from kernel analysis. As you will see through the slides, this didn't occur. There's a quite a strong convergence between the different ponderation levels. So we in the end understood that nevertheless the sort of ponderation you give to these indicators, the results will be quite similar. So for each scenario, we create, we went through a canal density estimation, and then we, in the end, start to compare them. Scenario number 5, we didn't go through it because we weren't considering the population and the vacant housing, just the requests. So this is, I will go through this sequence of slides a little bit fast because it's a kind of an animation for you to understand the little difference between those scenarios. What is going to change from the different scenarios is, just for you to understand, is here we have the vacant housing and the requests with different ponderations. Then we have the vacant with low consumption and with no contract. That's the only difference that we can find here. So I will go through the different scenarios, and as you can see, despite the scenarios are changing, the difference between the several scenarios are quite short. So this gave us the idea that the ponderation between the indicators were not an issue regarding the definition of the urban pressure zone. So in this way, we were trying to understand what kind of area we could get when relating all of these indicators in the different weights or with all the same weights. As we check that despite the different ponderation, we get very similar results, we decide in the end to use the ones that kept all the indicators in the same level of ponderation. But this wasn't enough. Sorry. What you are seeing also regarding these lines here, and that black ones, are the you remember during the afternoon I talk about urban areas that are available for urbanization. These are all, we have 160 of these areas. These are areas that are surrounded by urban tissue with edification, streets, whatever, and these are voids. So there are anything there, just terrain, just empty plots. This is important to us because we need to add to this analysis other analysis. Then we start to use some space syntax analysis. And why space syntax? One of the issues we put within this process was, okay, we are going to tax vacant houses, okay, in a gradual way to increase the taxes. But can I take a vacant house in a central area as the same as a vacant house in a non-central area, for instance? Is there a reason why I have a vacant house in a centrality and a vacant house in an area that is not that central? So we start to try to understand if the configuration of the urban system, of the territory, would help us to understand if the vacant houses could be understood as just for that vacant. If it is vacant, you will pay more. We use space index to understand that probably this wouldn't be the best idea. And then we start to try to identify the main centralities in the municipality and allocate to that the idea to in any way differentiate the vacant houses that are in centralities and the vacant houses that are not in integrated areas. In Matosinhos, we have these very clear central areas with another one that is not that evident, but it's starting to be. And why? Because of the price of the houses here, it's getting lower, higher and higher. That part is becoming attractive because there you have houses with low prices. So the north part of the municipality is having more people wanting to go there because of the prices of the houses. Huh? Yeah, I know. That brings us a problem to us. That is, everything that we create here in terms of urban pressure or potential urban pressure is going to have a problem here. This is the bridge. This is a lesser river. So this is a beach with a lot of traffic, and the pendular movements between the southern part of the municipality and the north part of the municipality is a problem right now, although because of the public transportation, etc. So this tendency for people to search for terrains or houses in the north of the municipality will in time increase the pressure of this bridge. But again, we understood that using space index only as to measure the potentiality of this centrality of these integrated or not that integrated areas of the municipalities wouldn't be enough. Then we cross it, the Excel analysis, with a function analysis. We have the master plan of Matosinhos was revised in 2019, and the team that did that revision they produce field survey about the functions of the buildings in the ground level of the city. So we have that survey that is being updated, and then we cross the potentiality of centralities with these activities that can generate function centralities. We understood that this could be useful for us to check if the potential configurational results were in line with what was happening in the city regarding the functions that we could find in the buildings regarding other functions that not only residential ones. And we also cross this with a measurement of entropy and again to understand that maybe the vacant houses in these areas of entropy, maybe they weren't, it wouldn't be fair to put them in a high municipal tax condition as in the central ones. So then we went to kernel and mix it and combine it with space syntax analysis, and the correlation starts to be quite evident that the pressure areas were associated with the configuration analysis that we had during the process of check the municipality through space syntax. But that wasn't enough. And then we also had another layer of analysis. We add the equipment, public transportation, and urban areas of rehabilitation / urbanization on top of it to also understand the quality of the urbanity that is installed and the capacitation of the territory. And we then cross this with the requests and the vacant houses. This is low consumption, this is no contract. And this is also another analysis using axial synergy and the vacant houses street. This in the left was made in GIS, that one using space syntax. And again, as you can see, vacant houses per street, the higher level of vacant houses per street is here, coincident with one of the main centralities of Matosinhos, that is Matosinhos Sul, and where the municipality, the camera, the city hall is also. Finally, we wonder the dynamic of the single urbanist operations, what the owners were promoting in terms of initiatives to build, that is translated in the building permits. So we did a kernel density estimation of the building permits, and again, a convergence between the permits and the area of the requests, the vacant houses, the central areas, and the equipments, and then the green areas. We also cross these with the areas that have a lack of green areas, and again to check the vacant houses with the urbanity, the installed urbanity. The idea is quite simple. A vacant house in an area of a great urban, a good urban index with equipment, green areas, services, equipments, commercial areas, etc., is not logic for an apartment or a plot to be not used as a rent opportunity or a buying opportunity. Is not understandable why I can have one of these in an area that doesn't have these sort of things because it's not that attractive, but have a plot or an apartment, a house that is empty or with low consumptions in this sort of area for us is not understandable. So from this process, we went to the delimitation of the urban pressure zone. Everything I'm showing to you now is a technical work developed within the planning division. As I told you, in the end, the decision is to the politics to have. So what we built was a process to help decision in a more informed way, and in a more conscious way, with more data available for the politics to make the decisions to where to delimitate the urban pressure zone. So we use the urban pressure zone evidence to start this proposal of the delimitation. And then we cross this with another topic that is important to this question, that is, within the master plan of Matosinhos, there are areas where you cannot have housing offer. For instance, areas for economic activities. They are mainly for economic activities. There are a low percentage of housing in these areas. Logistic, we don't want housing near the logistic, for instance. Rustic areas, we don't want housing in rustic areas because we have urban soil. So rustic soil is not to have housing. So we filter this urban pressure zone evidence with the urban soil, and only that is coincident with the urban soil was considered. Then again, we put here the areas for urban rehabilitation or urbanization. Why? We didn't want those that are in deprived areas to be aggravated by a higher tax also. These areas that are in the areas with good urban conditions, they could be aggravated. But those in deprived areas, we think that if they are already in deprived areas, we want people to renovate those areas in terms of urbanization. If you go and tax the plots of that areas with higher taxes, then the owners, we are not going to do nothing. Why? Because in the surrounding, we don't have services, we don't have commercial, we don't have public transportation, we don't have good infrastructure. And plus, we now have more taxes to pay. I'm not going to do wherever. So we enter here with this, also with this question about the limitation of the urban areas for urbanization. And the next step was try to get a more clear limitation considering these topics. And finally, we get the limitation that is now approved and being implemented. All the plots and all the houses within this area with more than 2 years of not being put in the market for rental or for sale or for to build, the owners are receiving a notification from the municipality telling them that their municipal taxes will increase from 6 to 12 times unless they start something, or a urbanization process or a building permit, or if they can justify why the building is there vacant. For instance, I have my father with some health conditions and he moved to my house because I'm taking care of him. Obviously, his house is with low consumption of water and electricity. That is a reason for us not to increase the tax. Or if, for instance, here in the upper part, there's a lot of houses that are second houses, the summer houses, for instance, because that's an area with good, amazing sea and beach, etc. So there are people that only goes there in the summer and holidays, whatever. So that is also a factor that can justify a house for having low consumption of water or electricity. Otherwise, the taxes will be increased. And so now we are in a process to notify all the owners, and they are responding. Some of them are getting their taxes higher, and some of them are able to justify why. And the idea is that the ones that cannot justify, they put the house or the plot in the market to be rent or sold, and then increase the level, the offer of housing in the market for rent and for sale, with expectation from our side that more offer will decrease the final price for rental or for housing or for buying a house in this urban pressure zone. And that's it. Yeah.
Gonçalo, ainda aí estás?
Sim. Obrigado.
Oh, okay. Does anyone want to start with a question to either to
Gonçalo is there.
yeah, David? Okay, back.
Thank you all for your presentations, especially given the late night. It can't be easy giving the presentation at this hour. I had a question to David. Due to the pressure, urban pressure zone, this seems like a very complex and exploratory process. And knowing a bit the environment of municipalities in Portugal and the pressure you have to constantly be responding to national and regional requests, I just wonder if you could tell us a bit about the process of actually implementing this in practice. So you had a team that wasn't maybe trained in all of these methods and you had to train them, and you still had to do this with all of the other responsibilities. And of course, obviously there was some acceptance throughout the municipality, otherwise this wouldn't have been done. But was this an easy integration? Were there specific steps that had to be taken? Were there specific posts that had to go, no, you can't work on that project because this needs to have higher priority, or does it need to be implemented with other things? Just in practice, how does this function? Thank you.
Yes, well, this urban pressure zone was a priority for the political executive.
Go. See? Well, yes, for start, the delimitation of this urban pressure zone was a priority for the political executive. So we have that request from the political body of the municipality. The question was, okay, how are we going to do this? We were one of the first municipalities to define this delimitation without going to a sort of already existing delimitation. As I told you, other municipalities, they attach the urban pressure zone delimitation to some other delimitation already existed, or the administrative delimitation of the municipality, or some delimitation already existed of urban areas for rehabilitation. In our case, we knew that that criteria wasn't going to be the best one. So we were wondering what kind of methodology we could assemble to fine-tune a delimitation that could be political, technical, and politically accepted and logical. As I told you, one of the things that I tried to do is to bring some of these methods to help decision. We didn't decide the final configuration of the urban pressure zone. It was a political decision, but it was based on the process that we set. And that helped them to help the decision in terms of the delimitation. Regarding the team, yes, Space Syntax was not there. Kernel estimation process was was not there, despite seeking GIS environment was already there, but kernel wasn't used. the statistic approach was made by an economist that we had in the division that is already retired. So I have to have another economist to do this. So it is a process among all other things, but it's an effort to try to put some of the things that we explore with these methods to actually do something in terms of planning. So that's a little bit of the track that we're trying to follow with with baby steps, really baby steps, really basic things. The complexity here is it seems complex because there's a lot of layers, but none of these layers per se is complex. There's no complexity there. It's just the way you assemble the set of layers you want to correlate in between the data that you gather. So it was more difficult for us to get the data because the data was quite dispersed in a municipal company, in a private company, in the different services of the municipality, all dealing with the data in their own way. So we have to set also that step. So that was more difficult than to actually do the kernel estimation analysis or the space index analysis, whatever. So it baby steps.
Oh, I'm sorry, I forgot without the mic you can listen through Zoom. I was just asking if everybody in the team understood the logic behind interconnecting these processes, or was it more of like, do it like this? Okay, but never asking why.
Always. And one of the steps is to demonstrate the evidence of some of the things. For instance, centrality. When we cross integration analysis with the function analysis, and I told them, look, this is quite logical to be this match, because if you have people going through this street, it's quite logical that maybe commerces and services places are there. So yeah, so this kind of obvious thing that you can put in line to understand this more abstract level of understanding, that helps. But yes, I have a great team and they do it. Although, for instance, space syntax, I had to try different technicians and now get one of them that's really fond of it and really loves it, and she do it all the time. She's really good. But I didn't start with her. I start with some other colleagues, and then I get the feedback. I understood the feedback. This is okay, but okay, no. This is okay, but no. And then one said, oh, this is okay, let's try it, let's explore it. So it's also a process. It's also baby steps, because as I told you, I have people in my team that are there for 30 years. So you need to introduce things by demonstrating the value of it and the logic of it with a low level of complexity in terms of the way you talk to them. It's keep it basic, keep it quite simple. Otherwise, they listen, but they don't get it. Understand?
Thank you.
Okay. Can you hear me?
Gonçalo?
Yes. So
Okay.
I would like to congratulate for the work presented, and in both presentations we are dealing in a way to design with numbers and information, and so it was interesting that you show different ways, like in urban planning, to use the numbers or to use this for performance. In the second presentation, but now we receive information from many places, and as we are talking about a conference of formal methods, I would like to ask you both how much information can we handle, because we are receiving information from a lot of places, and we are using it, But what do you feel about this balance of more information and being able to use it? Can you give us some feedback?
In our case, the first step we should do it for this kind of interpretation is to download the climate consultant software that is free. It's from UCLA, and it's a very basic one software, but allows you to understand the local climate of a new project that you can do it. And that brings you some information that you start to understand what is the strategies beyond the income of information that you get from climate information, from temperature, for moisture, for solar radiation, and so on. The second phase is try to use this kind of plugins, this Ladybug, Honeybee, other ones, to try to give you more in-deep information to help you to make choices in the project. But if you don't have the knowledge before how to design bioclimatically or in a passive way, it's useless. So even the use of information, if you don't have the background, if you don't study, if you don't get information from other sources that are fair, you cannot use it. You don't have support to use it. So we have to use it in a very careful way. Otherwise, it's just dropping information in drawings and showing nice pictures. It's useless. We have to be wise on that too.
Yeah, it's easy to be stuck on data. For instance, in this example I showed today here, we were quite careful in trying to understand what sort of data will lead us to the basic of the delimitation. For instance, after this work, we already did the charter, the municipal housing charter, where the sort of data was really higher and more, because we correlate the right to the housing to the right to the city. So we associate the response to the need of housing with the capacity of the territory in terms of urban qualities. So we had to introduce all the data regarding to what is urban qualities, for instance, green spaces, equipment, transportation, blah, 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 blah. So that is a context where more data was needed. So try to understand what are the goal of the work. Otherwise, as Anna was saying, it is also difficult for the team to deal with that flood of data and understand what we are going to do with this now. So we need to be careful about that also. But it's not easy sometimes. Sometimes we start something, and that happened in these two processes. Either on now we are developing the shutter for the proximity city, and data is even more complex because of the ratios between 10 and 15 minutes and et cetera, and then the level of issues that you start to cross. In a way, you get to a point that you say, I give up. I don't know how to deal with this anymore. So you have to go back and try to filter again and to move on. But that happens.
So in a way, we are building a path from information to knowledge. That is always the try to use this information in the right way. So I guess both cases we can see a little.
And to inform decision for us it's very important for
the issue about to inform decision, for the decision to be the more conscious as possible. Know in everything in the scenarios that you are setting, what kind of impact the decision you are going to take it will have. That is also important, because the ones who are going to have the decision on their hands, if they have this, they could decide in a more logical way. That doesn't mean that the political decision is always in line with the technical decision. That is another conversation.
Thank you.
Thank you for your presentation. I agree, let's say, it was kind of designing with numbers is kind of the theme here. And I would like to sort of continue a little bit on that idea of that it becomes so complex, is what I said here. And what do we do with all this sort of complexity? Do the people know what they are doing? Of course, you need kind of the knowledge first to be able to use this. But in a way, you can also turn around the whole thing. And it's actually very weird that we plan whole cities and areas without this understanding, because these areas and streets that we develop have an enormous environmental impact, and they will change people's lives. So we should actually understand what they are sort of how they are affecting our lives before we start building it. So I think, I mean, it's almost, I would say, it's very strange that we think this is complex. I mean, I know it, let's say reality is different, and it's very hard to get municipalities actually thinking this way. So I think it's very fascinating that you do this. But I would actually put the mirror back and say that, of course, we have to handle all this complexity and all these layers at the same time. But then when we do so, I think we should be more careful in describing it in a conceptual level first, to understand, let's say, what are the questions we want to answer? What do we want to know? And then in a way, you in the back office, let's say you do all these analysis and look into what's happening, and then you can sort of present the result. It's not so that you add layer on top of layer and then you all think, let's add another layer. You have a conceptual model that you know indeed that what you were doing, that if you have vacancies and you have a high centrality and a high density, well, this is a combination where you want actually that this valuable land is used. Yes. And if that's sort of lands, then you can find the data, do the analysis, and make sure that you know where the areas are. Yeah. So I think this conceptual level is very important to get the understanding also for people that do not have the technical skills to do it. And in a way, I think there we have to become much better, that we can explain those because those are not so easy to not so difficult to follow and accept for even laymen. And then the technicalities of making the kernel map and the centrality maps, they don't have to understand all those details. We don't have to understand how the television works. We just put it on if we want to watch television. So, but I was sort of, I wanted to give you I had a question in a way because now you used all this for one thing. And I think probably it will be more interesting and easier to implement this kinds of analysis in the municipality if you have a lot of questions that you can answer with it. And for instance, one that I thought immediately about that you showed, you had these areas that you can build on. I think those were sort of empty land and to make a priority of those would be very, very powerful if you have high centrality, low density, because then your infrastructure is already there, so you don't have to make those investments. So you can make kind of a priority of your developable land. So I think you can make a lot of these conceptual sort of narratives, and then you can use the same set of analysis to answer them. Then suddenly it becomes not so a lot of investments to do it and get the answers.
Yeah, that's a very good point. One of the things that is happening with the team is the higher level of perception about how all the topics are correlated. For instance, we start this work, and this work was the base for the municipal housing charter, because within the process of this work, we already identify a lot of things that we want to issue to the housing solutions. For instance, the capacitation territory. We want to offer solutions for housing in capacitated territory. We don't want to put houses in the periphery or where people have no public transportation or there are no coffee or a bakery and people have to drive the car to buy the bread for the breakfast. We don't want that. So by doing this, that level of perception of knowledge of the territory already help us to say, we didn't start the housing chart by in the ground in the zero level, in the ground level, we start already with these inputs. The proximity chart, the habitat chart that we are talking about. Oh, I forgot to say, in the legal framework for the housing charter, the law says that housing should be attached to the notion of habitat. And the notion of habitat is all the things that need to happen for the housing framework should work in a integrated way, in a more holistic way, if you want, not just for you to have a house where to live, but also have the street where the public transportation, the bakery, etc. So we are working with that concept for the proximity housing, proximity charter, and we start from to that charter. We start using the municipal housing chart and another work that we developed that is not here part is the green structure. So the correlation between housing and the green structure that we want to implement on the municipality is the base for the proximity, because we are dealing with equipment, public transportation, infrastructure, housing to create the idea of proximity. So these levels of complexity, as you were saying, they in the beginning they seems to be quite difficult to address, but in a moment you start to understand that they are all connected, and that by understanding 1, 2, 3, you start immediately to understand where that can lead you to in the other topic that you want to address. So that is something that help us to understand all of these works, not in a segmented or in an isolated framework, but that they are all connected. And in the end, the territory is just that, a system where all the systems are connected. And so that everything is integrated and then related to each other. So that is the kind of knowledge that this helps us to bring also regarding the level of correlations that we can establish between all of these topics, instead of, look, now I'm addressing this, period, dot, paragraph. 2 weeks after, oh, let's start all over again because we already forgot. No, we cannot forget that. This is the base for something else. This is the starting point for something else. So this is a incremental process, if you want.
So it's very late. We're going to start the closing session immediately. So
Just say goodbye to Gonçalo. Is still there, Gonçalo?
Yes,
Thank
David.
you, Gonçalo. And as Pinto Duarte, Gonçalo is with us from the beginning. Actually, before this is a symposium, this starts with a workshop in digital architecture that me and Gonçalo start to assemble in 2003 or 5, I don't know. And then we are with you also. So thank you. We thank Pinto Duarte, and we thank you also.
Thank you, David. Thank you, Franklin and George. Bye-bye.
Bye.
It's too late. So I'm going to be very quick. Well, thank you all for being present here in the Chamber of Architects, or Order of Architects, as you prefer. This is the north section of the Chamber of Architects. Well, thank you also to the institutions that organized this, namely the School of ESAP, the laboratory, the research lab, and also the collaboration with Portugal University. And of course, a special word to the keynote speakers today for the interest of the theme. Very, very briefly, I would say that our institution is very concerned about these themes. They are not easy, and they are not even in the search of interest, in the scope of the interest of everybody. They are complex for some, and very simple for others. The necessity of understanding the complexity of our profession is also important. Formal methods is something that we get to have to face. And we have to face and not to turn, like walk sideways or turn away or be afraid of. We have to face it because it's present in our near future, is present in nowadays, and also is something that we have to go towards the necessities of the service of the profession. That is important not only for architects, but to the public interest, which is important. And namely, we have to be the speakers in some terms of the necessity of that transdisciplinarity and the advantage of the new methodologies, innovation, new tools. The idea of tool is important, and the discussion about being tool, being cooperative, and being part of our work. So thank you for being in Porto, for all the ones that come from outside. And thank you for having this wonderful symposium. Thank you for those who organize. I hope you can enjoy the rest of the part of the city. There is also a formal method to explain how this city has a city center located 6 kilometers from the seaside. Is not casual, is not out of nonsense, out of nothing. It's not nonsense. There is a reason why the city has developed in the south part of the river, of the Douro River, and there's also explaining reasons for its morphology, which is a word that is important today, the morphology of the city and the way it has developed since so many centuries ago. I'm not sure if in terms of the urban planning, not the Matosinhos, but of the urban metropolis, some formal methods are being applied as they should. That is my doubt. And maybe I think there is a lack of architects and architecture in that definition of not only the urban form, but also the territory, the design of the territory. That is a concern that is ours. My main concern, for instance, the regional plan, the team of the regional plan doesn't have an architect. The regional plan north, the region north, which is quite big, doesn't have an architect with a very defined responsibility in designing that regional plan. And that is a problem that we have being architects, and sometimes we run away from our responsibilities, or at least we don't claim for our role in these demands. So thank you very much for the learning and the knowledge that you brought today to our house, and hope to see you soon one of these days, and so hope to see you again. And thank you very much. So.
No, it's not over. I have to thank you all again, but in the name of all the shares of the symposium. And I need to thank specifically to each person. So first I want to thank those who have been working for so many months with us to make this event possible. And in the first place, of course, I'd like to thank our co-hosts, our hosts and co-organizers, the Order of Architects and the North Regional Section. We found shared objectives in connecting academic research and architectural practice, as well And I want to thank you as well for the continuous support and dedication that you've shown to us throughout the last year. So, and Sophia in particular, thank you so much. You have contributed more than it's possible to say to this event. And also, Joanna, thank you so much for this last few days, and everyone else here in this house who has been helping for this last week. Then, of course, I also want to take this opportunity to thank the keynote speakers again for accepting our invitation to bring us their work, but also because they were invaluable contributors to the discussion, both within the sessions and outside the sessions. Another two people who deserve special thanks are Franklin and David for starting this whole thing 13 years ago. They have been working tirelessly on it for 7 editions. They're responsible for the way it has grown so far, not only as an event, but also as a network of people from different backgrounds, geographies, fields, and disciplines. We've seen mentorships and partnerships form in this symposium, as well as long-lasting relationships, both personal and professional, based on common interests and goals. And it really makes me happy to see some of you that are here for the second or the third, or Tassos, I don't even know anymore how many times you've been here, and to think that I may see you again in 2 years. And of course, I want to thank everyone else who is here for the first time. Everyone has contributed so much with their research and the discussion that we've been having these last few days. And I really hope that we'll see you in 2026. So the objective of this edition of the Formal Methods in Architecture Symposium was to explore the connection, or sometimes lack of thereof, between scientific research and architectural practice. It was exciting to have this opportunity to team up with the Order of Architects to examine why this gap exists and try to bridge it a little by bringing our research and methods to the attention of architect practitioners. Maybe we weren't as successful as we would have liked in bringing and joining architects and researchers to speak with each other, but we did have a little taste of what it could be like. And we've seen research that is deeply connected to practice, and practice that is deeply connected to research. The benefits of its applicability were made painfully evident in many presentations. And I can say painfully very literally, thinking, for example, of the presentation that we had this morning about the floods in Porto Alegre in Brazil. And we've seen also a very important research on development of materials and construction methods to improve construction efficiency and building sustainability, which is addressing very, very urgent questions. We've also seen people researching about this gap between practice and research, which is in itself very interesting, how they've used the scientific method to understand how to better connect scientific knowledge and design. And several participants have brought experiences in education that might already be contributing to creating a new generation of highly qualified architects. We're also conscious of and curious about the potential of these new tools and methodologies arising from academia. And from all of this, there was a central question that we've seen arrive in many instances, that goes beyond the complicated relationship between research and practice, but is also connected to it. That has to do with how much control do we as researchers or practitioners really have. Both these areas of architecture are deeply affected by economical, political, and social constraints. And as Franklin has pointed out yesterday, and David has pointed out that Franklin pointed out yesterday, researchers, architects, and urbanists decide only to a very limited extent how cities are designed. Its economical forces, namely real estate, holds most decision power. Nevertheless, as an that was a really awful word you use, incorrigible, evidence-based optimist, Franklin told us to keep going, and he spoke of the capacity of technological advancement to instigate social change, when contradictions within the mode of production become too deep. David, drawing from his own experience in between research and practice, emphasized the role of land property and urban policies, as well as of short political circles that are incompatible with long-term structural solutions. And we've seen this at play in the example of Matosinhos, both in your presentation and your presentation in the first day, the first presentation of the first day, where economic and bureaucratic hurdles stood between research results and practical action. So the short timelines to respond to problems led to an extremely short timeline to conduct proper analysis. And then related to this, but on another front, during lunch break, some of us have discussed how the precariousness of researchers and research centers also leads to a focus on short-term responses instead of long-term strategic research. So that leads me to another question that was very central during the symposium. In cases where the connection between research outputs and practice was not evident, many presenters were asked a variation of this question. So how can your research be applied to solve practical questions? How can it be used by architects or urban designers? And it seems that this was because of our intention to focus on the relation between scientific advances and design practices, that it can be understood as assigning primacy to applied research. But does all research have to be immediately applicable in order to be useful to design practice? And I believe that the response has clearly been negative. Some of the non-immediately applicable research that we have seen was connected to generative algorithms. As Franklin said earlier today, more than 20% of the abstract submissions that we've received for this edition of the symposium explored LLMs, GANs, or other forms of AI, which is a much larger proportion than many other years. And these tools make it possible to get a hold of and manipulate a large amount of data. This means we can add more and more complexity to our models, complexity that we're just talking about seeks to represent reality. But something else has been discussed, and is what extent do we need this complexity? Do we need to know all the facts? As focusing on knowing all the facts led us down a path where we now risk losing touch with theory and consequently forgo our understanding of how things work and why things work. Both Nabil and Joaquin touched on this. I heard all of us, or Nabil, say at least 10 times that first of all, we need to know what our research question is or our problem is when we're designers. Only then can we know what data we need and what we need to do with it. Joaquin used that analogy of the cooking robot that needs, first of all, a recipe. And the recipe is we have to know what dish we want to make so that we can figure out what ingredients we need and how we can use them. And this takes me to a thought that I shared with Wassim Jabi, and he thought I was being incredibly simplistic, and I was, but I'm still going to repeat it because it really comes out of a place of excitement. And also he isn't here anymore, so I think I'm fine. So he showed us a design process that starts from a design intention, which is in the examples that he used, that intention was often social. And back when I was studying architecture, I was taught that architectural design starts with the grand artistic gesture. Everything else that happens in that design is just a consequence of this initially largely objectual intent. So what I saw him propose, even though he might not agree that it's what he proposed, was a design that started from those consequences, from the way we want people to live in space, from how sustainable and healthy and sociability inducing we want the spaces that we design to be. And then we click a button and the grand gesture appears. And of course, I did hear Meta's side here about it being both fully art and fully science, but that was, I'll keep to my simplicity for this moment. And following this idea of intentionality, I want to bring back Meta's questions to Tassos in the same questions, where what really stood out that it is not for intentionality needs knowledge. It's not enough to find an algorithm that can actually that can predict human behavior in space, we must always understand why that algorithm works. And then while I understand and agree with Franklin's assessment that God is also in the details, or that global features can be found in its local parts, I object to the analogy, because God is by definition something that is always beyond the grasp of human understanding. And the importance of human understanding is what stood out to me from both of today's keynote speakers. With the growth of black box types of AI, it seems that it is more urgent than ever to make non-explicit knowledge explicit. We must be able to state goals and intentions and understand why and how certain results are produced. So on the first day of the symposium, Pinto Duarte told us that we need to understand what we can build to know what we can design. And now on the last day, I think we can say that we need to understand so that we can design. I and all the shares, we really hope that you have enjoyed being here, that you are taking something new with you for your research and practice, and that we'll see you again in 2 years. And before I let you go, I have to remind you that those of you who want to join us tomorrow for the tours, we promise they won't end at 9 p.m. And we are meeting in the Museum of Serralves at 10 o'clock, I think. That's right. Yeah. So thank you, and see you tomorrow or in 2 years.
And thank you, Catarina.